Hey Collin, looks like you got yourself a bar of copper there. What's up? Planning on bonding a strain gauge to that?
Yes, sir. We have a CEA gauge with a 09 STC. We're going to be bonding to this copper bar.
Are there any special things you have to do because it's copper?
Yeah, we don't want to use a neutralizer as the copper doesn't like that, so we're going to just be using the conditioner A.
So where did you find the fact that the neutralizer was supposed to be omitted? Is that in B129, surface preparation?
It is. If you look at the chart in the back and you go under the copper, it should outline everything you need to use.
Very good. Okay, what's our first step then?
First step is we're going to degrease using CSM3. Take a gauze sponge, fold it in the quarters. And wipe in one direction. You can see the contamination coming off of that. We'll probably hit it again. One more time. Okay.
That should
That's
do.
good.
What's the next step?
Next, we're going to use 320 grit silicon carbide paper. And do a dry braid.
So that removes the gross surface contamination and oxidization before you use the conditioner A?
Correct.
Or, excuse me, the neutralizer 5A?
Correct. Okay. I'll take another gauze sponge, fold it in the quarters, and remove as much of the material that we just sanded as possible.
Get away the gross contamination.
Okay. Next, we're going to take the same 320 grit silicon carbide paper, and we're going to do a wetter braid with the conditioner A,
Which is a mild phosphoric acid solution.
Okay. Starting with the inside and wiping away so that we don't put any more contaminants back into the area that we're just working with.
So wiping back and forth would be a bad idea. You'd
That's
recontaminate
correct.
the area.
Okay, now we're going to do the same thing, a wetter braid, but with the 400 grit.
And the 400 grit gets us to about a 60 RMS surface finish. Is that about right?
That's about right. Same way we did before, we'll start in the middle and work out so we don't recontaminate the area. Okay, now where we typically use the neutralizer, we're going to actually use some distilled water.
Or DI water.
And we're going to do a scrub with the cotton tip applicator. And we're looking to make sure that the cotton tip applicator is coming up white, or as close to white as possible. So this one's getting a little dirty. I'm going to go back over it with another one.
Try it. Try it. So the DI water is basically to get the gross contamination off and try and remove most of the acidic material from the surface.
That's correct.
And you'll normally use neutralizer 5A to get the pH to a very high number, but in this case the copper doesn't like the neutralizer 5A, the Bo Peep ammonia.
Okay, I think that's pretty good. We're just going to dry it again. Alright. So
you're going to be using this CEA 09-125UW120 strain gauge. The reason we're using a 120 is because the copper material is probably one of the better heat sink materials, and so we're not so concerned with grid self-heating. So now we got to prepare and position the gauge on our clean glass plate.
Mm-hmm. Okay, using the blunt tip tweezers, I'm going to be grabbing the gauge by the bottom end near the solder tabs so that we don't disturb the grid.
Now, is that the shiny side up or the dull side up?
That's the shiny side up. The dull side you want down towards the specimen that you're attaching it to.
So that's the bondable side.
Correct.
Shiny side up, dull side down.
Next we're going to use our PCT2M installation tape. We're going to take the first couple inches and discard it in case there's any contamination from it sitting out in the open air. And give it a little tug so it doesn't curl up on me. I'm going to lay it over the top of the gauge so that it's nice and flat. I'm going to make myself a little handle here so I can easily grab it.
You're folding over the end of the tape to make little handles?
Correct. And now I'm going to lift at a very shallow angle so that I don't bend the gauge.
By bending the gauge you might damage the grid, change the resistance or something like that?
That's correct. Okay. Now I'm going to locate where I want to apply the gauge, and I'm going to wipe it over the surface. Okay. Now we're going to lift it again from one end at a shallow angle, just past the edge of the gauge, maybe a 1/4 inch or so, and fold it back on itself. We're going to be using the M-Bond 200 adhesive, but we're going to start with the catalyst C. Now, you don't want to use much, so you're going to knock the edge of the brush on the inside of the neck of the bottle at least 10 to 12 times to try to get most of it off. Okay. Then one wiping motion.
Fingers in the way.
You're going to wipe across the gauge. And then you're going to leave it for 1 minute to air dry.
Now you'll notice he lifted the brush after he got off the gauge and on the tape, because when you lift the brush there's a small dollop of the catalyst C left behind, and that would have been a contaminant. So we allow this to air dry for how long?
About a minute.
Okay.
Okay, once the catalyst is dry, we're going to now take our M-Bond 200 adhesive, and at the junction where the tape meets the copper bar, we're going to take 1 drop and place it at that junction. And then taking a folded gauze sponge in quarters, I'm going to put the tape back over, and I'm going to use 1 swiping motion, and I'm going to use the thumb pressure. About 1/3 of a white thumbnail is enough pressure.
Is that calibrated?
It's calibrated.
And how long do you hold it?
We're going to do that for 1 minute. pressure for 1 minute, and then we're going to remove the pressure and we're going to let it sit for 2 minutes.
Why do we leave it sitting under the tape for 2 minutes? Does it have to finish catalyzing?
Yes. After the 1 minute of thumb pressure, we let it sit for 2 more minutes. Now we're ready to pull the tape off. Visual inspection shows that the bond looks good under the tape. So we're going to start with the one end and we're going to peel the tape back 180 degrees on itself.
That puts the adhesive into shear, which is the strongest?
Correct. Okay.
Now we do a final visual inspection. What are you looking for?
Looking for any inconsistencies, any bubbles, anything like grit underneath it. Making sure it's uniform.
So what do you think? You got a good installation there?
It looks good.
All right. CEA gauge on copper 09 STC.